Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11 and class 12 topics. So today we will continue our discussion on ionic equilibrium. In the previous video I described about the working of buffer solution. Now today we will discuss about pH of buffer solutions. Okay, now if you wish to go through the previous videos, you can find the link right here, or you can find the link in the description as well. So please stay tuned. Now, pH of acidic buffer. Okay, now let's take an example of acidic buffer. So for acidic buffer, we need two things simultaneously. We need two things simultaneously. See, one is weak acid and another one is salt. Weak acid and its salt. Let's say concentration of salt is C1. Let's say salt's concentration is C1 and CaCCOH concentration is C2. Okay, now what will happen now? See, I took concentration of salt and acid different so that we can get an answer which will not be depending upon a particular concentration. So C1 here, C2 here. Now tell me which one is a strong electrolyte. I hope you know that CH3COONA is a strong electrolyte. Why? It is a salt of weak acid and strong base. So it will give us CH3COONA, CH3COO minus plus Na plus. Now earlier it was C1, so it will be 0 in the beginning. This will also be 0 after some time. It will be 0. It will be C1 and it will be C1. It is your T equals to T. Okay. Now you have one more thing in your system, that is CH3COOH. It is weak electrolyte. I hope you know. So if it is weak electrolyte, so it will be dissociated like this. Means in forward direction it will be very less dissociated, and it will be mostly existing in form of CH3COOH. So what it will give us? It will give us CH3COO minus plus H plus. Now it was C2 in the beginning. It was 0 and 0. After some time it will become C2 minus C2 alpha. What is alpha? Alpha is degree of dissociation. C2 alpha. Here also C2 alpha. Up to here anything doubt? Good. Now what we can write? We can write here net CH3 COO minus. Now can you tell me what is our net CH3 COO minus? We have net CH3 COO minus equals to how much? C1 plus C2 alpha. C1 is coming from what? CH3 COO minus. CH3 COO and C2 alpha is coming from what? CH3 COOH. You're getting this thing. By CH3COO minus कहाँ से आ रहा है? It is coming from CH3COONA means salt, and also it is coming from acid. Okay. Now I am going to say one thing. Alpha will be very small. Alpha will be very small. Why? Because CH3COOH is a weak acid. CH3COOH is a weak acid, so alpha will be very small. But in presence of CH3COONA, which has one ion in common, so this alpha will become much smaller than its usual value. Regarding this thing, वैसे ही alpha बहुत छोटा होता है, but CH3COO minus के presence में alpha और ज़्यादा ही छोटा हो जाएगा. What do we call this phenomena? Common ion effect. So it will be nearly equal to how much? C1. Why? Because C2 alpha is very small. Is this thing clear to us? Good. Now can you tell me what will be net concentration of CH3COOH we have? CH3COOH is how much? See, we had C2. Out of that, C2 alpha is removed. So net concentration is C2 1 minus alpha. This is your net concentration left. Now again I am going to say one thing. Alpha is very small. So I can also write it as just C2. Why? Because alpha is not just smaller but much smaller than 1. You're getting this thing? Good. Now I hope you know, for this equilibrium we define equilibrium constant K. We also call it acid dissociation constant. Now how will we write here? Let's see. K will be written as, if you want to write K from this equation, how will you write? You will write concentration of CH3COO minus multiply by H plus divided by concentration of CH3COH. I hope it is clear to us. Good. Now let's say K equals to how much? What is CH3COO minus? CH3COO minus where it is C1. What is CH3COOH? C2. So it will be nothing but C1 into H plus divided by C2. Now what will be H plus from here? H plus will be Ka C2 by C1. Now if I take log on both sides, so log H plus will be how much? It will be, see, this is your A and this is your B. So log AB equals to how much? It is equals to log A plus log B. Okay, I hope you remember this. Now what will be pH? pH will be minus log concentration of H plus. pH will be minus log concentration of H plus. So how much you will get from here? You will get minus log, see, just putting minus before this, so I will get minus log Ka minus log C2 by C1. Is this clear? Good. Now see, what we can write this? We can write this as pKa, isn't it? We can write here pK minus log K is what? pK. And see, I am writing it like this, plus log C2 upon C1 to the power minus 1. Are you getting this? What I have done here, I hope you remember this formula. Log A to the power X equals to X log A. So same thing I did here. Here it was written minus 1. So I put this minus 1 as a power of C2 upon C1 and like this. Now can you see what I am going to get here? I am going to get pKa plus log C1 upon C2. Okay, C2 upon C1 to the power minus 1 is what? C1 upon C2. Now what is this? This is your pH. Is this clear to us? Now what is here? What is this C1? C1 is concentration of what? Salt. What is C2? C2 is concentration of acid. This equation is clear to us? Good. Now we got this formula of pH. pH equals to pKa plus log concentration of salt upon concentration of acid. Now see here one thing, we can write one more thing. pH equals to pKa plus, I hope you understand, the concentration of salt I can write like this. I can write like this, millimoles of salt upon volume in ml divided by millimoles of acid divided by volume in ml. Why? Because concentration equals to what? Millimoles upon volume in ml. Yahi molarity hota hai. This is your molarity. See, volume in ml get cancelled. What we got? pH is equals to pKa plus log millimoles of salt upon millimoles of acid. Now this is an equation which I will be using a lot. This is the equation which I will be using a lot. This equation and this equation are called Henderson Hasselbach equation. These are called Henderson Hasselbach equation. Okay, although no need for this name, just understand the pH, these two formulas will be used for acidic buffer. Now, I am not going to derive a formula for basic buffer. Let me tell you, their derivation is never asked. So it will be better if you remember this formula. Okay, now if I ask you, can you tell me about for basic buffer? Let's say I have basic buffer. Now, in basic buffer, what I will have? I will have base. I will have weak base instead of weak acid. Salt will still be there. Okay, there I will not find the formula for pH. There I will not find the formula for pH. I will find the formula for pOH. Now, can you guess the formula? Can you guess the formula based upon this? See, everything is going to be same. Same concentration, same dissociation, same C2 minus C2 alpha, like everything will be same. So I'm writing here, pH will be how much? pH will be, see, here it is written pK. But there I don't have acid, I have base. So I will not write pK, I will write what? pKb plus log. There I have, here I have salt. In basic buffer also I will have salt. So I will write salt upon, will I write here concentration of acid? No, I will write concentration of base. Are you getting this thing? Or instead of this, Instead of this base concentration of salt upon concentration of base, you can write moles of salt upon moles of base. This is the formula for POH of basic buffer. Remember, this is your POH, not pH. So if you want to find pH, you have to do one thing, just pH will be 14 minus POH. This is how you will find the pH of basic buffer. Question is clear? This derivation is clear to us? Good. Let's move forward. Now let's see a small problem. Here they are saying, can you tell me which of the following combination will result in buffer formation? Which of the following will result in buffer formation? Now, you must remember one thing. In order to form a buffer, you should have a weak acid along with its salt, or you should have weak base along with its salt. Also, you can have a salt formed by weak acid and weak base. You can have a salt formed by weak acid or weak base. If these three conditions are there, remember, weak acid combination with salt, weak base combination with salt, and a salt formed by weak base and weak acid. If either of these three you have, so that means you have a buffer. Remember this. Okay. Now there are four options. I will solve one for you. I will solve just one for you, and that is D. That is D. It looks big. Rest three you have to tell me in the comment section whether they are forming or not. Okay. So just see. Look at this D option. What we have here, we have HCl along with CaCO2 and NaOH all together. Here 2 moles, 3 moles and 3 moles. Now first of all you tell me, will there be any reaction? Will there be any reaction? Please pardon the background noise. You know this video is being recorded at my home. So tell me, will there be any reaction? Definitely there will be reaction, bhai. Why? Because see, acid, base. Acid, base. Remember, village 1, village 2. They are so strong enemy of each other. So acid and base, they will start cutting each other. You're getting this thing. Now I hope you understand HCl is a strong acid and this is your weak acid. This is your strong base. So it's like strong base is fighting against strong acid and weak acid. Strong base is fighting against strong acid and weak acid. So tell me, who will react with NaOH first? Whether it will be strong acid or it will be weak acid? It will definitely be strong acid. So firstly, reaction will take place between HCl and NaOH. What we will get? We will get NaCl and H2O. Okay. Now how many moles of HCl you have? 2. How many moles of NaOH you have? 3. In the beginning it will be 0, it will be 0. Now don't need to write this water. Why? Because I told you in the very beginning of ionic equilibrium, the story of ionic equilibrium will be floating in water only. It will be in water, so no need to write water moles. Everything is water here. Now, do you find any limiting reagent here? Here, HCl is limiting reagent, so it will left 0. It will become 1. Eventually it will become 2 and no need to write water. Okay, now think about this. I told you, the NaCl means Na plus and Cl minus. They don't have any contribution towards pH of solution. NaCl means salt of strong acid and strong base has no contribution towards pH of solution. So we will not consider the mole of NaCl. No need. You don't need to consider the mole of NaCl, KCl, KBr, doesn't matter. Whatever salt is formed by strong acid and strong base, no need to consider that in ionic equilibrium for pH calculation. So see, you got one NaOH left. So will this battle stop? No, this battle will not stop because you have 1 mole of NaOH left. Now HCl is dead. HCl is dead. Now it's time for revenge. Who will take the revenge? CaCO2. It is also weak acid, but it is an acid and it is enemy of NaOH. So now what will happen? This CH3COOH will say it's time for revenge. It's time for revenge. Against whom? Against NaOH. Say how many moles of CH3COOH you got? 3. How many moles of NaOH you got? 1. These two will react and they will give you what? CH3COO Na plus H2O. Now, what will happen? In the beginning it will be 0 and no need to write water. So who is limiting reagent here? NaOH. So how much CaCO2 will be left? 2. How much NaOH will be left? 0. How much CaCCAA will be found? 1. And how much H2 will be found? No need to mention. Okay. Now, in the end, when everything is done, what is left in your system? When everything is done, what is left in your system? I'm giving you option. Just think and answer. Do you have HCl left? Do you have HCl left? No. Do you have NaOH left? No. Do you have CH3COOH left? Yes. See, you have got CH3COOH left. How much? 2 moles. So you have CH3COOH in your system. Anything else you have in your system? Can you think about this? Yes. See, CH3COOH, it is also left here. Nah. So you also have CH3COOH in your system. Means you have weak acid and you have salt of it in your system altogether. So they will give you what? They will give you buffer. They will give you buffer. So yes, this will generate buffer for sure. Okay. Remember, for buffer you need 3 things: weak acid with its salt, weak base with its salt, or a salt formed by weak acid and weak base. Are you getting this thing? I'm not saying salt only. I'm saying salt of weak acid and weak base. Means, am I talking about CH3COOH? No, I'm not talking about this. It is salt of strong base and weak acid. Are you getting this thing? Okay. So if any of these 3 combination you are having, so you are having buffer. Now check A, B, C on your own and tell me your answer in the comment section. Now the next question is, find the pH of a solution formed by mixing 50 ml of 0.1 molar NaOH and 100 ml of 0.1 molar CH3COOH. Given pK of CH3COOH is 4.78. Okay. Now this type of questions you will generally find in ionic equilibrium, where they will give you some mixer. They will give you a mixture where 2 or more than 2 substances will be mixed. Now your task will be somehow you have to find what is happening because of this mixing. Now for instance, do we have any reaction here? Will we have any reaction? Yes. How did I find out? See, I am adding base in what? Acid. So when I add base in acid, what I will get? Salt. Let's see, this reaction will happen. NaOH will react with CH3COOH to give you what? It will give you CH3COONA plus water. All the water you don't require to write here. Why? Because everything is going on in water only. Okay. Now, can you tell me how many moles or millimoles of NaOH you have taken? Let's find out. Please ignore the background noise. Okay. Millimoles of NaOH equals to how much? It will be 50 into 0.1, that is 5. Now how many millimoles of acid I have? Millimoles of CH3COOH will be how much? 100 into 0.1, that is 10. Means I have this 5, I have this 10. These are millimoles. In the beginning it will be 0 and no need to write water. Who is limiting agent? As you can see, NaOH is limiting agent, so it will be 0. Now it will be left 5 and it will be 5. It will be 5. And do you need to write water here? No, no requirement for water. Now think about this. Please pardon the background noise. Okay. Now I hope you can see I have what is left in my solution. Do I have CH3COOH? Yes. Do I have CH3COONA as well? Yes. So means I have combination of weak acid as well as its salt. So means these two combination, these two things all together means they are forming what? Buffer. And that to which type? Acidic. Reading this thing. Now, when you have found out what you are actually getting, now what we will do? We will apply simply formula for pH. So what is the formula for pH? pH is equals to pH is equals to pKa, acidic buffer na, plus log millimoles of salt upon millimoles of acid. Now how much I will get? 4.78 plus how many millimoles of salt I have? 5. How many millimoles of acid I have? 5. 5 got cancelled out. So how much I will get? 4.78. What is this? What is this? pH of weak, pH of solution formed by these two components. You're getting this thing? Good. Next question is, they are saying it requires 20 ml of HCl to neutralize a solution of NH4OH. Now, they are asking you pH when you have added 10 ml of NH4OH, 10 ml of HCl in NH4OH, they have given pKb of NH4OH is 4.8. Okay, let me explain your question. Suppose you have NH4OH solution, you want to neutralize it. So how much ml volume of HCl is required? 20 ml. Now they are saying I am not adding 20 ml, I am just adding 10 ml into that. So tell me what will be the pH of solution when I have added 10 ml of HCl. This is very good question, and this question, although it's not that difficult, but it includes so much concept in it. Okay, let's see. Suppose you have NH4OH here and you have HCl here. Okay, they have not given any information about NH4OH, how much amount of NH4OH, how much moles we have, how much concentration we have of NH4OH. Nothing they have provided. Now let's assume that here I have A millimoles. I have A millimoles of what? I have A millimoles of NH4OH. Now can you tell me, pause the screen and think one thing, how many millimoles of HCl will be required for neutralizing this NH4OH? Means if I say NH4OH plus HCl, they will be reacting to give you NH4Cl and H2. Now the question is, if I have A millimoles of NH4OH, so how many millimoles of HCl I will require? I will require A millimoles of NH4OH. Why? Because I want to fully neutralize this now. Regarding this, so 0, 0, A. Regarding this thing, when this will happen? This will happen when I have added HCl equals to how much volume? 20 ml. When you add 20 ml, so somehow all the millimoles of NH4OH are neutralized. Regarding this thing, good. Now, but what you have done? You have added just how much volume of HCl? Just 10 ml. Means you did not do this thing. You did something else. See, let's say in the beginning you have A millimoles of NH4OH. Now you added just 10 ml of HCl. So means if you have added 20 ml of HCl, you will add A millimoles of HCl. When you add 20 ml of HCl, you will add A millimole of HCl. Now you are adding just 10 ml of it. Now you are adding just 10 ml of it. Can you tell me how many millimoles you will add of HCl? You will add A by 2 millimoles, isn't it? If 20 HCl contains A millimoles of A millimoles, so 10 ml will contain A by 2. Now what will happen? Let's say it was 0, it was dash in the very beginning. Now after some time, who is limiting agent here? HCl. So it will be 0, it will be A by 2, it will be A by 2 and no need to write water. Okay, let me explain one more time. See, this is your 1. It was one experiment, T equals to 0. You added how much HCl? You added HCl equals to 20 ml. Okay, I assumed NH4OH was A. And why I am writing A of HCl here? Because they are saying that HCl is neutralizing your NH4OH. So that means HCl millimoles should also be how much? A. Otherwise NH4OH will not be neutralized. So A millimoles here, okay, complete neutralization. But I did not add 20 ml. How much volume I added? Just 10 ml. So it means only A by 2 HCl I must have added now. So because of that, I will be left with A by 2 millimoles of NH4OH and A by 2 millimoles of NH4Cl. This is clear? Good. Now can you tell me, what do you have in your solution? Do you have NH4OH in your solution? Yes. Do you have HCl in your solution? No. Do you have NH4Cl in your solution? Yes. See. Do you have water? Yes, of course I have water. Now what is this? This is presence of weak base. And what is this? This is presence of salt. So this combination will give you what? Buffer. Which type? Basic. Are you getting this thing? So how will we apply? How will we find the pH of this solution? pH will be found by Henderson Hasselbach equation. What is that? It is if POH is equal to, remember we will not get pH here, we will get POH. So pH is equal to how much? pKb plus log millimoles of salt upon millimoles of acid. Oh, sorry, millimoles of base. Okay, now let's see what is pKb given 4.8 plus what is millimoles of salt we have A by 2. What is millimole of base we have A by 2. So log A by 2 upon A by 2. Now log A by 2 upon A by 2 is what? 1. Log 1 equals to how much? 0. So this is equals to what? 0. So pH is coming as 4.8. But did they ask pH to us? No, they asked pH. So pH will be how much? pH will be 14 minus 4.8, that is 9.2. pH is equals to 9.2. Clear? Good. Now next thing that we have to discuss is buffer capacity. Although it's this buffer capacity, no longer questions are asked in NEET or JEE Main, but still let's understand it's not that difficult. Now I hope the word suggests everything. Buffer capacity means what is buffer? Buffer resists in change in pH, but it has got a limit. It's not like you add a full bucket of acid or base in your buffer solution and you will say okay, pH will not change. We're getting this thing. This is not going to happen. Buffer has a capacity up to a certain extent it can perform well. It can perform well as a buffer. Otherwise, it will not be performing. For example, let's understand the buffer capacity. Buffer capacity, how do we define it? We define it as moles of strong acid or strong base required to be added in 1 liter solution of buffer so that its pH can be changed by 1 unit. Okay, what is the meaning? You have a buffer. How much volume? 1 liter. 1 liter buffer you have. Now add a strong acid or a strong base. If you will add strong acid, pH will decrease. If you will add strong base, pH will increase. So moles of strong acid or strong base required which can change the pH of this solution by 1 unit. Either 1 unit decrease or 1 unit increase. If it happens, so we say that our buffer is dead. Buffer has lost its capacity. No, it is no longer acting as buffer. So this is called buffer capacity. There is a formula as well for normally formula based question. For normal formula based question, buffer capacity formula is beta is equals to moles of strong acid or base added in 1 liter of buffer divided by delta pH, means moles added upon change in pH. Okay. Now, if you want to find buffer capacity, there is one more formula. Derivation is no longer in our syllabus. So beta is equals to how much? 2.303 concentration of acid or base. Of course, weak acid or weak base. Multiply by concentration of salt divided by concentration of weak acid or weak base plus concentration of salt. If you apply this formula, you will directly get the buffer capacity. Okay, is this clear? Means if this much amount, whatever buffer capacity is, if you add those much amount of salt or those much amount of acid or base in your buffer's pH will change by 1 unit. Are you getting this thing? So this is your buffer capacity. Now this is very famous question. Question is the maximum buffer capacity is observed when concentration of salt is to concentration of acid or base is 1:2, 2:1, 1:1 or none of these. Okay, this question can be solved mathematically and this question can also be solved theoretically or logically. So mathematical portion is not in our syllabus, so I will focus upon this theoretical term, okay, or logical term. Now tell me, what is the job of a buffer? Buffer has to fight with acid also and buffer has to fight with base also. Means if you add acid, so buffer must fight that acid so that pH should not change, and if you add buffer or if you add base, then also buffer must fight with it so that pH will not change. Okay, I hope it is clear. Now think about this. When you will be called a good buffer? When you can fight with acid better, or when you can fight with base better, or when you can fight both with the same efficiency. Think about this. Tell me, if I have CH3COONA, CH3COONA is what? Salt. So salt is not CH3COONA actually. Salt is CH3COO minus. It is the anion which is reacting with what? It will fight against H plus. Okay. And who will fight against Who will fight against base? It's your acid. Acid will fight against OH minus and salt will fight against H plus. Now, if you have basic buffer, so in basic buffer NH4 plus means it is coming from NH4Cl. This is your salt. Salt is not NH4Cl, it is actually NH4 plus. So it will be fighting against whom? OH minus. And who will be fighting against H plus? It will be NH4OH. So they should be equally powerful, or their power should differ. They should be equally powerful, so that whether your acid comes or base comes, your buffer can fight equally. Are you getting this thing? So we say a buffer which has equal concentration of both acid as well as salt, or base or salt, will perform best against any given acid or base combination. You're getting this thing. So best buffer capacity is observed when your concentration of salt is to concentration of acid or base is what? 1:1. Now if you change this, let's say you have this ratio is 1:2. 1:2 means 1 is your salt, let's say CSCCW minus, and 2 is what? Let's say your acid, let's say CSCCWH. So this buffer has tremendous capacity to fight against OH minus. If OH minus will come, this acid will simply kill it. But its capacity is not that good against fighting this H plus. Why? Because CSCCW minus concentration is not as good as we have for acid. So its performance will reduce. If base will come, it will fight. But if acid will come, its reactant or its capacity will be lesser as compared to others. Are you getting this thing? Good. Now, so 1:1 ratio if you are maintaining of your buffer, so just understand your capacity will be maximum. Let me tell you, if ratio is 1:10 or 10:1, means ratio means 1 is 10 times, or one acid is 10 times of salt, or salt is 10 times of acid. Up to this concentration only you get to see buffer as working. If you have concentration beyond this, let's say if you have concentration ratio, let's say 1:20, so your buffer will not perform good. Are you getting this thing? If you have ratio at like 30:1, buffer will not perform well. Are you getting this? So always remember ratio should be 1:1 to 1:10 or 1:1 to 10:1. If you have this ratio, then only your buffer will be working properly. Sometimes this question is asked, so you just remember this. Okay? Okay? Shall good. Now, in this video up to here only. So in the next video of ionic equilibrium, I will be discussing about the salt hydrolysis. Okay? And one more thing I want to tell you, please try to go through this question. I have attached a DPP with this video. In the description you can find the DPP link. Please solve that. If any doubt arises, ask me in the comment section. Rest we will discuss later. Have a good day. Bye.